The next thing that we're going to want to do is to calculate balanced angles and balanced distances. So like everything's like amazing and stuff. So what's really nice about this is that it's trig. So the adjusted length is now the balanced latitude squared plus the balanced departure squared. So now that we have these nice little latitudes, we can take the square root of the sum of the squares and get an adjusted length, just like we did with the error. We can also now adjust the azimuth. It's the inverse tangent of departure over latitude. And this is a little backwards because you might think, well, it should be y over x. Why is it x over y? And that's because we're measuring from the y-axis, when normally when we're doing tangent, like traditionally you think I'm measuring tangent from the positive x-axis. So I feel like a picture would help. So like normally whenever I'm measuring tangent from here, so it's opposite over adjacent is y over x. But now I'm going to do a different color because somehow that's going to matter. Whenever I'm measuring from, well, I could even measure the same angle here. This is a different angle. And in this case, my opposite over adjacent is x over y. So this is why we have the departure over the latitude. Now the thing that we do have to take into account is the fact that when we're doing inverse tangent, we need to pay attention to the idea of whether or not we're in this quadrant, this quadrant, this quadrant, or this quadrant. Because if we have two negatives, because you know how to do calculus, right? Or at least trig. So if we have two negatives, I could be down in here, and that would give me a negative over negative is a positive. So to a tangent function, that would give me the same thing as this. So it's automatically going to give me this angle here. So I'm going to have to adjust it over here to get that angle. So that is something that we have to keep in mind. So we need to make sure to adjust the azimuth to make sure that we're actually in the right quadrant, and we'll take a look at that in a sec. Okay, so let's see, we're going to do balanced distances and angles, or azimuth. All right, so I can actually hide this, and I can hide this. Actually, I can hide pretty much all of this. I'm not going to hide my azimuth because I want to see it. Just to see kind of what it looks like and make sure I'm adjusting correctly, because my balanced azimuths and distances should be very, very close. It's just a question of making it perfect. So distance azimuth, like azimuth, and I'm going to play with borders because it makes me feel like I have control over my world. Okay, the distance is the square root of the sum of the squares. That squared plus that squared. Beautiful. It's actually going to take me an extra thingy to do the azimuth, and I'll show you why. So I'm going to make an extra temp angle here. So there's actually this really, really amazing function that I recently learned about in Excel. So I was looking for tangent, and so we talked about there's this issue with tangent based on what quadrant you are, but what's amazing is if you're in Excel, oops, a tangent, there's this arc tangent thing, and it says it returns a number from negative 90 to 90. But then if you look over here, it has two inputs, and it says in radians between negative 180 and positive 180, which means that it's actually taking into account which quadrant it's in. Now it says x and then y, but remember that we're flipped, so it's y and x. But this is really, really, really amazing. So I'm going to go arc tangent 2 of departure and then the latitude. So this is something that you can't do on a regular calculator particularly well. And in fact, I'm kind of shocked that Excel is able to do this. And then you look at it and you go, but no, this is really, really bad. And you're like, well, no, but wait, because remember that Excel is going to think in radians. So I need to convert that to degrees by multiplying by 180 over pi. Okay? Yeah, like that. All right. These numbers seem weird. Did I do them backwards again? Maybe. Maybe not. That is my x number, so I need to do backwards. There we go. Alright. So those are my numbers. Now, so like some of these numbers are already really good. So like this is 150, and I know it should be close to 150 because that was what my original measurement was. So that's supposed to be close. The 42 is exactly the same. And basically these are the same thing. If I add a 360 degrees, that's the 186, which is very close to that. So what I want to do is I want to say if this value is less than 0, I want to add 360 to it. Otherwise, just leave it as it is. And whenever I do that, I can pull it down, and indeed, I've got a beautiful, so I'm going to hide this for just a second. So well, maybe I don't want to hide it because then I'll lose it. So I'm going to come over here and I'm going to paste these beautiful values, and you can see how close they are. And if I go like this, they look like the exact same number. But they do become a little bit different, just different enough that it's totally worth the effort now.